Thank you so much for the support, guys, and this is my website, and this website link will be given to you in my description box. So here you can just go through my website so that you can get the particular videos of Mfcs or whatever the videos I have published. You can get it from here, and in case if you have any queries, you can just click on let's chat and you can just say hi, and if you have any suggestions or if you have any queries, you can just put it here so that I can receive those messages and can reply you back within very few minutes. Okay, so this is a software is about Mfcs Unit 2 set theory, introduction, operations on binary sets, principle of inclusion and exclusion. The next videos will be on relations and functions. In case if you miss any videos, you can check the links in the description or you can check the playlist in my YouTube. Okay, let's begin with introduction of set theory. What is a set? A set is a collection of objects, and these objects call themselves as elements. Suppose we can take an example of set of natural numbers or set of alphabets. This is the representation of a set. The capital letter denotes the set, particular set we are taking, and the elements of that set should be written within the flower brackets. Okay, so these A, B, C, D are called elements. Suppose we are taking A, which is belonging to S. This symbol denotes belongs to. Okay, so here A is an element which is belonging to S. We are coming to E alphabet, that is not belonging to S because it was not within this set, right? So we can make it as doesn't belong to. Let's take another example of this, which is a set of even non-negative numbers that are less than 10. Which means non-negative means it should start from 0 and less than 10, which doesn't include 10. If it is less than or equal to, then it includes 10. Okay, so we are taking these 5 numbers and we can make it a implicit definition. Okay, so this is the implicit definition where we are denoting with some capital alphabet and we are writing this can be read as E equals to X, where X belongs to N. There is Y belongs to N such that X equals to 2Y. Let me explain this. Okay, so we are taking a set and we are taking a element and that element belongs to capital N. In set theory, capital N denotes natural numbers. Okay, so the element is belonging to natural numbers, and there is another element Y which is also belonging to natural numbers such that X equals to 2Y. Because why we have written this formula? Because we are considering only even numbers. Even numbers means which are the multiples of 2, right? So that's the reason we have written this formula. Got it? And why this is called implicit definition means we are using a predicate, and there is also one thing called explicit definition, which is this one, which is very easy to understand. Okay, so don't complicate more. I just want to let you know about what is implicit and explicit definitions mean. And now we're gonna learn about subset. What is a subset? Subset means, suppose we are taking two sets A and B. Okay, we are taking two sets. If every element of A is an element of B, suppose A is containing 0, 2, 4, 6, 8 and B is also containing 0, 2, 4, 6, 8, then A is called as the subset of B. Got it? And it is represented by this. Okay, A is subset of B. Let me explain you with a clear example. Okay, suppose we have taken a set A, set B and set C. Here it was asking the relation between these sets. Here AB is the subset of ABC, right? Because these elements are present in this set. So this set is capital B and this set is capital A. So we're gonna say B is the subset of A. And similarly, if you take C set, A, C are also the elements that are present in capital A. So we're gonna say capital C is the subset of capital A. Okay, and we have another set, capital W, which is having element C, which is present in both C and A set. So we're gonna say capital W is the subset of C as well as the subset of capital A. Okay, now we're gonna learn what is a proper subset. We have learned about what is subset, right? So what is a proper subset means, if we are taking set A, we're gonna say A is a proper subset only if A doesn't equal to B, which is represented as A subset of B. Okay, this is the symbol of proper subset. This is the symbol of subset. Okay, suppose if you are taking A equals to 1, 2, 3 and B equals to 1, 2, 3, 4, this is the proper subset, which is A which is not completely equals to B. There are some elements of A in B, but not all the elements. If there are complete elements, then it is called a subset. Okay, now equal sets. What is equal sets? Two sets we are considering, X and Y, are equal if X is the subset of Y and Y is the subset of X. See here in this example, if you see, X is a set that is containing of 1, 2, 3, 4, 5 and Y is also a set that consists of 1, 2, 3, 4, 5, right? So this is called as equal sets. Okay, then what is power set? Power set is a collection of all subset of set, a particular set. Suppose if you are taking a particular set A, the collection of all its subsets are called as the power sets and it is denoted by P of capital A. Suppose we are taking an example of find power set of set A equals to 1, 2, 3. So it includes each and every subset, nothing. So this pi represents nothing. Okay, nothing is also a subset and 1 is a subset, 2 is a subset, 3 is a subset, and 1, 2, 1, 3, 2, 3 and 1, 2, 3. So all the subsets collection is called as a power set. Then what are finite and infinite sets? Finite set is something which are having the elements can be countable. Suppose this we can count the elements, it's 3. So this is the finite set. Whereas infinite set which are not countable, like suppose if you take the elements of all natural numbers, there are many infinite natural numbers which can't be countable. In that case what we'll write? A in the flower brackets we'll write 1, 2, 3 the starting elements and we'll keep so on. Okay, then what are Venn diagrams? You know, Venn diagrams are the best part where you can draw something and explain very clearly. This is a diagram that helps you to represent the sets in a very easier way that anyone can understand. Suppose you gonna want to represent X is the subset of Y. So X is a subset of Y, is a proper subset of Y, which means Y consists of X set, right? So that's the reason Y is containing X within a particular universe. Okay, so Venn diagrams are very easy to explain and get the topic to be mostly understandable. Now we're gonna learn about the operations on sets, which is binary sets. Okay, so first one is union. What is union? Set of all the elements that are members of set A and set B or both. So we are taking two sets, right? So the considering all the elements of both the sets is union and it is denoted as A union B. Okay, so here A union B equals to X, where X belongs to A or X belongs to B. which means the A union B consists of the elements of A and elements of B. Here suppose we are taking an example of A equals to 1 2 3 4 5 AB and set B consists of A B C D E. So the union will be all considering all the elements of both the sets, and the Venn diagram is this one. So we are combining these both the sets. This is the representation of A union B. Okay, so this can be represented as like this, like each and everything will be the union. Okay, so this is the union of two sets. Then what are the properties of this? The properties can be defined as A union A equals to A, right? So if you take A union A, the same elements will be represented, right? See, if you see here completely AB, AB, we are not repeating those elements, right? So what are the exact elements without non-repeating we are taking? So A union A will be the same 1 2 3 4 5 AB, and A union pi, that means A union nothing, an empty set, which means absolutely A, and A union union universe, which means the complete all the elements will be taken, right, than A, because A is only containing 7 elements, whereas universe is containing all total all elements, right? And A union A dash, which is A opposite of A, again comes to union, because everything will be considered again. Next, A subset of A union B, and B is also a subset of A union B, because all the elements of A and B will be considering with A union B, right? Will be consisting there. Next, A union B equals to B union A, which is a commutative property, and associative property also works here. Now we're gonna learn about intersection of two sets. What is meant by intersection? Set containing all the elements that belongs to A and B. So it is denoted as A intersection B, which is A intersection B equals to X, where X is an element that belongs to A and also X belongs to B, which are belonging to both the sets, which are common in both of the sets to B. Okay, now here if you say example capital A set, capital B set, and we are finding the intersection, we are taking the common elements between them, right? So here A is containing in both of this set, D is containing in both of this set, F is also containing in both of these sets. So this is the intersection, the most common one. Okay, so this is called as intersection of A intersection B. Okay, so these are the thing between the common one. Okay, and what are the properties then? The properties of intersection is A intersection A, the common elements of A set, both two similar sets is the same set, right? And pi, we're gonna take pi only because there will be no matching elements. A union A, U equals to A, where union is the universal set. When we are intersecting this, sorry, it's an intersection here. Okay, so when we are taking this intersection like A intersection union, it will be only A, because within the universe A elements can be matched, and obviously A intersection B will be a subset of A, and B is also a subset because some at least one or two elements will be similar, right? And it satisfies both the commutative property and associative property as discussed in union. Now mutually disjoint sets. What are mutually disjoint sets? Which is collection of sets is called disjoint only if every pair of sets in the collection is disjoint. Okay, so don't confuse with this definition. Let's go with an example directly. Okay, so suppose if you are taking a set X and set Y and set Z, which are having some particular elements and its subsets, right? So here if you see carefully, A comma B is one set and C is one subset and here A is one subset and B comma C is another subset, which is this is different from this and this subset is different from this, right? So X intersection Y is an empty set and Y intersection Z is an empty set. Obviously X intersection Z is also an empty set. So now read the definition. If every pair of sets in the collection is disjoint, so every pair with another one is completely a disjoint one. So these are called mutually disjoint sets. Okay. Now the third operation on sets is difference of two sets. Difference of two sets, let's take capital A and capital B sets, that is the set of elements that belong to A but not B. So this is the Venn diagram. So A minus B includes the complete elements of A but not B and is denoted as A minus B, and the implication one is A minus B equals to X, where X belongs to A but not B. Okay, and A minus B can also be denoted as, like, the difference of two sets can be represented in this three representations. Okay, and difference of set is also called as relative component of B in A. Let's take an example. We are taking this A equals to 1 2 3 4 5 6 and B equals to 3 5 7 9. So whatever it might be, A minus B means whatever the elements that are only in A but not including in B. So 1 2 4 6 are only the elements of A because 3 and 5 are making a subset of B, right? So that's the reason we are avoiding the complete subsets of B and we are writing the elements that are only related to A but not related to B. Coming to B minus A, we have to write the set elements 9 comma 7 because 9 comma 7 are not included in A. So we are removing completely the subsets of A and we are writing only the elements that belongs to B. Got it? Now coming to its properties, these are the properties like A complement equals to U minus A. You're gonna learn about this complement soon in the next page. Okay, and A minus B equals to A intersection B dash, and these properties are very important when you are coming to solve the problems. Okay, so please be careful with the properties of every operations because that can help you to solve the problems very well. Coming to complement of a set, let's we take U will be the universal set for any set. Okay, then U minus A is the absolute complement of A and it can be represented as negation A or A power C or A dash. Okay, so suppose we are taking U which is containing all the positive integers and A is containing 1 3 5 and so on. So the complement will be which are not containing in A, the complete opposite of A. That means 2 3 4. So here A is containing all the odd numbers, so the complement of A will contain all the even numbers, and this is the representation of Venn diagrams. And coming to the properties of complement, these are the properties of the complement. Okay, like A union A dash will be union and union dash equals to pi. A intersection A dash will be pi, because this is completely opposite to this, so nothing will be similar in this, right? And pi dash is union. The opposite of empty set is universal set, and A complement of whole complement is A. Okay, so A union B whole complement is A complement intersection B complement. It will be very easy for you to remember these properties only if you have gone through Mfcs Unit 1, and the links will be given in the description below. Okay, coming to De Morgan's law, these are the De Morgan's law and we gonna solve, we gonna prove it LHS and RHS soon. Okay, the next operation as symmetric difference of two sets, let us consider A and B are two sets, and the symmetric difference will be the consisting of all the elements that belong to A or B but not both, and it is represented as A plus B or A triangle B or A plus B. These all can be represented as asymmetric difference B. Okay, so A plus B equals to X, where X belongs to A and X doesn't belongs to B, or vice versa. Okay, so here is the complete description of Venn diagram, where you can see A, B, which are elements either in A or in B but not in both. Okay, and coming to this properties, you can see A plus A equals to pi, A plus pi equals to A. So the symmetric difference, if A, it means nothing because similar elements shouldn't be there. Okay, coming to this one, this is the formula of how to solve the symmetric difference. Okay, let us first go into the problem so that you can clearly understand what is symmetric difference. Okay, suppose we are taking two sets C and D. First we have to find the difference of both the sets C minus D and also D minus C, as considered like this, right? So first we have to do C minus D and D minus C. I hope you have already understood the differentiation, right? So C minus D is something, the elements that contain only in C but not in D. D minus C are the elements that contain only in D but not in C, right? So we have to take both and we have to union it. That gives us the complete result of the symmetric difference of C plus D. Okay, they contain the elements which are in A and B but not both. Coming to the last topic, principle of inclusion and exclusion. Suppose we are taking two sets A and B, then the number of elements in union of two sets is the sum of the numbers of elements minus the number of elements in their intersection. So this is the formula. So the union of both the sets will be the sum of elements in both the sets minus the intersection of both the sets. Coming to this problem, we can see they have given A union B union C and asking us to show that this equals to this. So first we will come with LHS, and at every step remember this principle of inclusion and exclusion formulae and implement at each and every step. Suppose coming to A union B, we are dividing with this formula. That means A union B means A plus, this is complete one considered as 1. So A union whole part of B union C is considered as B. So A plus B union C minus intersection of both. And again here it represents this formula. Again we are applying this formula here. So wherever the formula is appearing, the type of statement, we have to apply the formula and come to the conclusion of this. Got it? And these are the problems that are related to the concepts that we have discussed till now. Okay, so these are the very easy problems and will help you to solve more. So I have asked you to remember the properties, right? If you remember this property or this property, so these are the properties that can help us to solve these problems very well. Okay, so let me explain this problem and we'll come to the end. They have given in a class there are 50 students, where 20 students play football and 16 students play hockey, which means we can take A as 20 students, B as 16 students, and who play both hockey and football as 10. So A intersection B will be 10. Now by using principle of inclusion and exclusion, we gonna get A, B and A intersection B, so that we gonna know about A union B, right? So A union B is who play everything, which includes everyone, right? So that we got 26. So who plays neither football or nor hockey? So these 26 people are the one who play both the games, like either any one of the game, right? So who play nothing, or we have to subtract this union from the number of students, that is 50. So by this we can come to the conclusion that 26 are playing at least hockey or football or both, and 24 students are playing nothing, no sport. I will just end up with a small problem. Here we are taking A union B minus A, and it was asking us to show that A union B. Now we can take B minus A as B intersection A dash from the property of difference. Okay, so from this property we are taking this and we are implementing, and now A union B intersection C, it is in this form, right? So that's the reason we are implementing A union B intersection A union A dash. A union B intersection A union A dash is obviously pi. Okay, it's an empty set. Okay, we have learned, right, the pi, right? So this is the pi. So A union B intersection pi is obviously A union B. So please learn the properties very well so that those can help you to solve the problem wherever it is required. So anytime you have to be in your mind to check in which state it is. Suppose if it is in B minus A, you have to get the idea that you have to implement in B intersection A dash. For getting that idea, you have to be very good with the properties of each operations of binary sets. In the next video, we're gonna learn about relations and the complete topics up to diagrams. Okay, so this will be the part 2 of unit 2. Okay, thank you, have a good day and all the best for your exams. Download some particular PDF, like whatever the PDF that I discuss in this videos will be provided to you by here. So you can just click on Mfcs unit 1 part 2, and here you can see the download symbol. So from here, if you click on download, it will be automatically downloaded. Okay, so this is the way you can check or you can download the PDF, and you can also check my videos, like the particular unit video link and the PDF link also will be given to you, so that you can just check it out. And if you have any queries, please let me know. I will be very happy to reply back. Okay, thank you.